Question 22, we have a cuboid ABCDEFGH. The measurements that have been given here are shown in the diagram. Calculate the length of A to G, so that's the dashed line that we have here. So whenever you have a length of a 3D object like this, and you've got measurements in terms of the base, the width, and the height, or the length, width, height, whatever you want to call it. This is going to involve either Pythagoras in different dimensions or your trigonometric ratio, SOHCAHTOA, in different dimensions. So the fact that we have this, I'll highlight it here in red, this length that we're looking for, what you want to do is try and find the right angle triangle that involves that line. Now, there is one obvious right angle triangle that connects with this, and that is involving G to C right there. If we also have what I like to call the shadow, whenever you've got this sort of diagonal line, like a 3D diagonal line like that AG, the shadow of it, if you had a light shining from above, would be what's in blue there. And that blue line and that green line are perpendicular to each other. So there's our right angle triangle as it stands. So the end game is to try and figure out the length of x there. And by doing so, we will use this right angle triangle with the height 3 and this blue line, which at this point in time we don't have. But if we figure out what the blue one is, we can then get the red one after that. So that's the immediate right angle triangle that jumps out at me. Now there's technically another two ways you can do this. It depends on which perspectives you want to look at this cuboid, but that's the most immediate one that I think most of you will go with. After that, we've then got to figure out, well, how do we get that y? That y itself, this blue line here, is also diagonal. So we've got to figure out, well, what right angle triangle contains that blue line. If we look at it down the way, what you have is y is this diagonal line, and we have this dimension 5, and the other dimension 7, forming a right angle triangle on the base, with the right angle being in there, like so. So what we end up with here is Pythagoras twice. We're using Pythagoras in this triangle here in order to figure out what y is, after which we will then use Pythagoras in that triangle there to figure out what x is. So, going with the motions, a squared equals b squared plus c squared. Sorry, a squared plus b squared equals c squared. Smaller sides, 5 squared plus 7 squared equals c squared, which then becomes 74. So root 74 equals c. I don't need to turn this into a decimal because I'm not done yet. We're going to now take that answer over here. So y is root 74. And we do Pythagoras all over again here. So we're going to have root 74 squared, which just for the record turns into 74, plus 3 squared is the other smaller side, will equal x squared. So that's going to give us x squared as being 83. And then when we square root 83, that will give us our length of x. Square root of 83 is equal to 9.110, so on and so forth. And then rounding that to 3 significant figures, we get x equals 9.11. Part B, calculate the size of the angle between AG and the plane ABCD. So the plane ABCD, just to highlight this, is the surface that is on the base. That surface there. And we're trying to figure out what angle this line in x makes with that. Now, whenever you're looking for an angle between a line and a surface, what you want to do is have the shadow of the line, which I've highlighted there in blue. That shadow is the angle between these two. So the surface ABCD being this, the shadow that that red line makes on that surface is y, and you're basically looking for the angle in between these two. So this triangle here is the one that we're going to be using. Just to redraw it, the relevant colors. I can also put in the information from previously. I'm going to write root 83 because it's technically more accurate than this. But as you'll see in a moment, you don't even have to use it. We have 3 there, and then our base was root 74. I Again, I'm going to use that instead of the decimal, and we're looking for this angle here, which we'll call theta. Now, in this right angle triangle, you can use sine, cos, or tan, because we actually have all three sides here, so it doesn't matter which you choose. I'm going to choose these two, just because why not? Tan is the first one that pops up into my head, but it really doesn't matter. Opposite over adjacent, and then I can do inverse tan to find the angle. 3 over root 74, and type that in the calculator in one go. It's going to give me 19.225 and change. And then this question wants us to leave it to one decimal place, so that's what we're going to do, 19.2 degrees.